Let's take a look at this example. In this problem, we're supposed to find the resistance R. Please notice that all resistors are the same. They have resistance R. And we're supposed to find the total current. We're supposed to find the current which goes through this resistor, power across this resistor, and voltage across this resistor. So I'm going to find R first. Please notice that this is series parallel circuit. R total is given. So what we're supposed to do first, we're supposed to simply write the formula for this circuit. How I would do that? I would do something like that. We have resistor and resistor. They are in parallel. And the resistance is the same. So the total resistance of these two resistors is going to be simply half of them. So for this part I'm going to say that this is R divided by 2. R divided by 2 is the total resistance for these two resistors. Why? Because they are in parallel and the resistance is the same. If it's not specified, don't worry about it, because this is R and this is R, they are the same. These two resistors, the equivalent resistance, okay, is connected in series with this resistor. Okay, see that we have a node over here, so it makes these two resistors connect in parallel and in series with this one. That's why I'm going to simply write over here plus R, right? Plus R. Next, you're supposed to realize that one half we can rewrite this like this is like 1/2 R plus R, right? It's like invisible 1 over here. So it's like $1 plus half a dollar is equal how much? 1.5 R, right? $1.5. 1/2 plus 1 is equal 1/2. Remember, anytime there is no coefficient next to the variable, there is always invisible 1. So 1 plus 1/2 gives me 1.5 R. So this is the resistance for this part of the circuit. Next, you're supposed to, we can redraw the circuit if you want to. We can say that we have circuit looking like this right now. We have R, and in parallel with it, we have another resistor which is equivalent to these three resistances connected together, and this is equal 1.5 R. Of course, this is my 9 volts, and we have this, my R total is equal 2.4K, and so on, but right now we concentrate on resistance R. Now, these two resistors are in parallel. So we can say that R total is equal R times 1/2 1.5 R over R plus 1.5 R. Why? Because these two resistors are in parallel. So what I have over here, R times R gives me R squared. So I have 1.5 R squared. And R, like this is like invisible 1 over here, 1R plus 1.5 R, this is equal 2.5 R. So R squared and R will cancel out. So let's take a look what we'll get over here. We have R total is equal 1.5 R over 2.5. So this is equal, you can use the calculator if you want to, is 1.5 divided by 2.5. this is equal 600 milli. We can say this is 0.6. So this is 0.6 R. Okay, so we have something like this. R total is equal 0.6 R. In order to find R, I have to divide both sides of my equation by 0.6. This and this will cancel out. So I have something like this. R is equal R total divided by 0.6. And this is equal, R total is 2.4K divided by 0.6. Okay, this is 2. So now we can use the calculator to find value of R. R is equal, we have 2.4 exponent 3 divided by 0.6. This is equal 4 kilo ohms. So R is equal 4 kilo ohms. So every resistor in this circuit has value of 4 kilo ohms. Next, we're supposed to find I source. Okay, we have given voltage source and we have R total, so we can find the current source. So we have I source is equal voltage source over R total. So this is equal 9 volts divided by 2.4 kilo ohms. And this is equal 9 divided by 2.4 exponent 3 equals 3.75 milliamps. 3.75 milliamps. This is my current source. Next, I can find the current which goes through the resistor R. Okay, this is my first resistor over here. This resistor. Let me call this. Let me call this current I1. Okay, so I1 is equal voltage source over R. Voltage source is equal 9 volts over R, which is equal 4 kilo ohms. So I1 is 9 divided by 4 exponent 3. This is equal 2.25 milliamps. 2.25 milliamps. Now, if I have this current, I can find this current. Why? Because I source minus I1 will give me the current which will go over here. And this is nothing else, just my IE. Because this current will split into two currents, and these two currents are going to come together again, and they are going to give me IE. So this is my IE. So IS minus I1 will give me IE. So I can say that IE is equal IS minus I1. And IS is equal 3.75 milliamps minus 2.25 milliamps. So IE is equal 1.5 milliamps. Those of you who don't know how to use the calculator, you can just take a look what I'm doing. 3.75 exponent 3 negative minus 2.25 exponent 3 negative equals 1.5 milliamps. So we found IE. Because these two resistors are identical. So the current which will go through each of them is going to be simply half of this one. Okay, because these two resistors are identical, so each resistor is going to carry just half of this current. So I can say that let me call this, by the way, I2, and this is my I3. So I2 is equal to I3, and this is equal IE divided by 2. And we found that IE is equal 1.5 milliamps divided by 2 is equal 750 microamps. Okay, so this is basically the value of the current which will go through resistor over here and the resistor over here. These two resistors, okay, are going to carry 750 microamps. Next, I'm supposed to find the voltage across this resistor. Okay, so voltage we simply find by using Ohm's law. So we have VA is equal R times I2. And this is equal 4 kilo ohms times 750 microamps. So I have 4 exponent 3 times 750 exponent 6 negative equals 3 volts. So if this resistor has 3 volts across itself, this one is going to have also 3 volts across itself because they are in parallel. Next, we're supposed to find PC. PC, I can say this is, we can solve this value by using, let's say, the following formula. I3 to the second power times R. I3 we found is equal 750 microamps to the second power times resistance 4 kilo ohms. And this is equal 750 exponent 6 negative square times 4 exponent 3 is equal 2.25 milliwatts. 2.25 milliwatts. Okay, so just let's take a look one more time. If we found everything, we found IS, we found resistance, we have VA, which is basically voltage across this resistor, we find PC, which is the power at this resistor. So we can say that the problem is solved.